Okay, so I stumbled upon this concept of XORSAT filters, and it's really fascinating. It's like a super efficient version of a Bloom filter.
Wait, what? A Bloom filter? I thought they were already pretty efficient for set membership. What's special about these XORSAT filters?
Right? So here's the kicker. XORSAT filters are static, meaning once they're built, you can't add more items, but they optimize memory use like crazy.
That's wild. So they save space significantly compared to regular Bloom filters. How does that even work?
Exactly. They compress data so well that they're great for large datasets. Imagine saving bandwidth for tons of users.
Oh wow, so it's not just about efficiency on the user side, but also in processing overhead, right? That's genius.
Yes, and despite their optimized memory, they still have super fast querying speeds. It's actually comparable to Bloom filters.
Hold on a sec. So they're fast even with high false positive rates? That sounds like the best of both worlds.
Totally. But here's where it gets interesting. You can actually specify the parameters for how you want the filter built.
Wait, what do you mean by parameters? Like, how do those impact the filter's performance?
Good question. Depending on the parameters, you can create filters that are smaller but take longer to build, or vice versa.
So it's all about finding that sweet spot between size and build time? That's really strategic.
Exactly. And they even have sample parameters based on recent studies, which is pretty cool for research applications.
Oh, so if someone needs a filter tuned for their specific application, they can just adjust those parameters? That's pretty user-friendly.
Yes, and let's talk about the querying part. The approach for querying an item is super straightforward.
I'm all ears. How does that work? Is it easy to implement?
For sure. Once the querier is ready, querying just checks if an element might be in the filter. It's a simple call.
That sounds seamless. But what if the element wasn't added? How does it handle that?
Great point. If it isn't added, the filter just returns false, so you know for sure it isn't there. So reliable.
Wow, that makes it a lot easier than I thought. And the added metadata retrieval is just icing on the cake.
Right? You can retrieve the metadata you stored for each element, which adds a layer of usability.
But hold on, can this filter be serialized, like saved and loaded later?
Yes, you can serialize a querier, so you save it to a file and load it back. Super practical for persistent storage.
That just makes it even more flexible. I love how adaptable these filters are for various applications.
And here's another cool tidbit. They're being used in some cutting-edge research. There's a whole paper on it.
No way, that's amazing. So it's not just a theory, it's getting applied in real-world scenarios.
Exactly. The implications for data processing and storage are huge, especially for systems handling massive datasets.
This blows my mind. Have you ever thought of how many applications could benefit from this?
All the time, from cloud storage to even AI training processes where memory is crucial.
And considering the US government is behind it, it's likely got some serious backing and research.
Definitely. It's fascinating how something developed in a government project is now open for anyone to use.
This sparks so many ideas. I can imagine developers tweaking those parameters for unique uses.
Totally. So putting everything together, it's amazing how much more efficient these filters are.
Right? Just think about all the compressed data out there and how this could reshape storage solutions.
It's kind of thrilling to think about the future of data management with these innovations.
So if someone were to get started with this tech, where would you recommend they begin?
Honestly, maybe dive into that sample test provided with the library. It's a perfect hands-on way to learn.
Great suggestion. I can't wait to check it out and see firsthand how it all works.
Absolutely. I'd love to hear back on how it goes. There's so much potential here.
For sure. This conversation really opened up my perspective on data filters and their impact.
Same here. It leaves me wondering what else is out there waiting to be discovered in filter technology.
Totally. If we think about the rapid advancement of tech, I feel like we're just getting started.
Exactly. Imagine how much this could evolve in just the next few years.
And it's exciting to think about how these tools will redefine what's possible in data science.
So much potential. Let's keep this convo going when we uncover more about this realm.
I'm in. Here's to more fascinating discussions about AI and data innovations ahead.